So this is about the quantum observer effect and its implications. This picture, by the way, I made using the AI drawing program called Leonardo.ai, which is astonishingly good. It doesn't always give me the image that I wanted, but actually this one turned out to be pretty nice too. So let's assume that's the quantum observer. So what is it? The quantum observer effect refers to the idea that not only the idea, but the observation that before you observe a quanta, a photon or electron or elementary particle, but what is there is considered a wave, something spread out over space and time. But when you observe the particle, it localizes in space and time. So this suggests that the elementary world, that something about the nature of observation or measurement changes its behavior. So one way to think of this is sometimes that a photon is shy. It knows it's being looked at and it changes its behavior as a result. So one easy way to see this is through a double slit optical system. So if you're not looking at which of two little slits that a photon goes through or an electron, what you see at a camera after the light passes through, or electrons, or almost any elementary particle, is an alternating band of light and dark. This is exactly what you would see if light was behaving like a wave. But if you do know which of the two slits that the quanta goes through, then you see a different pattern. Usually it's portrayed this way, as though you see two bright bands. It's not exactly that, but it's close enough to illustrate that it's quite different than the pattern that you would see if you did not know which of the two slits it was going through. So this is called gaining which path information. If you gain which path information, you so-called collapse the quantum wave function, and you go away from waves and you go into a particulate direction. So this is where the idea of light having a wave and particle, it's like a wave and a particle at the same time, depending on what information you gain about it. So why does this happen? Well, let's turn to Neil deGrasse Tyson, who's a well-known science spokesperson. And I'm going to do this for several other people like Neil, to first go through what contemporary physics has to say about why is there this quantum observer effect? What is it about? Well, so what Neil would say is that the quanta are tiny. So to see an electron requires an interaction which would disturb the electron. And you can substitute photon, atom, all kinds of elementary particles here. To see it requires an interaction. And it's happening all the time. And it has nothing to do with consciousness. So let's see him talk about this in a clip.
Exactly. But particles, electrons, atoms, all of this, it happens all the time. And this was a very disturbing discovery in the 1920s. We're in the centennial decade of the discovery of quantum physics in the 1920s. Because you discover this, I want to see what you're doing. Oh my gosh, you're not going to let me see what you're doing. Because the light I shine on you in order to see it is, so it's really, it's not so much an observer effect, it's a measurement effect.
Exactly.
Okay, get the human brain out of it. It's just the device to measure you can't know it. Okay.
Right.
So let's get on to, so it has nothing to do with consciousness.
Okay, it has nothing to do with consciousness. Sorry, Neil, it's actually much stranger than that. So there's something called the Renninger effect, the Renninger negative measurement effect, also known as the interaction-free effects. And there's a picture of Mauritius Renninger, who proposed this idea in the 1950s. To make it simple, I'll just use this illustration. So assume that we're going to fire an electron through two slits, and then we have some kind of observing screen. So we fire the electron, it goes through the slit on the right, but we had a detector there, so we know that it went through there, and the detector goes bing, we know it. And as a result, the interference pattern goes away, right? It wouldn't go away the way I just showed you. It would go away the moment we set it up this way. But basically, you end up with a particulate pattern. So something about knowing where the photon was going made a difference. So far, this is the conventional thing. But what if we had this setup? So we have the same setup, but now we're shooting one electron at a time. It goes to the other slit, and there's nothing there to look at it, so there's silence. But the thing is, we know we shot the electron because we see it on the screen. We know it didn't hit this detector, so we knew we can infer that it went through the other detector, the other slit. So this is called interaction free. We know something because it went through the slit that didn't have a detector. And nevertheless, even though it goes through this other slit, our knowledge of it causes the screen to show a particulate pattern. So this is why we know that knowledge alone collapses the wave function. And actually, you'll see a number of, I'm not going to show here, but you can find out that you ask conventional science spokespeople about why there is an observer effect, they almost never talk about this. This Redinger effect is not, it's part of the mainstream in physics, and we know that it's true because it has been experimentally tested in a variety of ways, but somehow this is sort of waved away as though it's not meaningful. Well, it's extremely meaningful because it means that knowledge alone will collapse the wave function. Here's an article from Scientific American that just came out a few days ago about why quantum physics isn't as weird as you think. It's weirder. So what they point out here is that if you imagine that the physical world at a deep level is like waves pushing through water, well, then Heisenberg's uncertainty principle is not quite so weird. And superpositions and even entanglement are not quite so weird. Even quantum tunneling is not that weird. But what's very weird is still the quantum measurement problem. Why? Because imagine someone speaking to a crowd, sound waves spread out across the crowd, and everyone hears the speech. In the quantum world, the sound wave would spread out, but if a single person in the crowd perceives it, the entire sound wave would concentrate itself in that person's ear, and no one else would hear it. So this is where the wave metaphor breaks down really significantly. So how else is the quantum observer effect understood and explained by the status quo? So I'm going to use this physicist, Sabine Hassenfelder, who, as you can see here, is doing quite well, 1 million subscribers to her YouTube channel. And for this particular talk that she gave, over an hour long on YouTube, almost 600,000 views as of when it first came out in last November. So she's a very popular popularizer of physics, and she clearly is quite smart and a good educator. This is then how this is understood by the status quo. So I'll play a little clip here.
Why did some physicists like von Neumann and Wigner think that consciousness is necessary to make sense of quantum mechanics? And can consciousness influence the outcome of a quantum experiment? That's what we'll talk about today. Von Neumann's argument was that a particle in a superposition can cause superpositions of the things it interacts with. This leads to superpositions of the entire measurement apparatus and everything that follows from that. Say you use the measurement outcome to decide whether to blow up a bomb or not. Then you get a superposition of a bomb that's blown up and one that didn't. And that leads to a superposition of a world in which you died and one in which you didn't. And a superposition of worlds in which you go on to win the Nobel Prize and one in which you didn't, and so on. Von Neumann said that this chain of events needs to be cut somehow, and since everything in physics seemed to keep the superpositions alive, he thought the collapse had to be caused by something extra-physical or psychophysical. It had to be the conscious perception of an observer. The observer either sees a bomb explode or not. The Wigner and von Neumann interpretation has problems because all interpretations of quantum mechanics have problems. Reinterpreting maths just pushes problems around like bumps under the carpet. In the Wigner-von Neumann interpretation, the problems manifest themselves as conscious observers who have inconsistent knowledge about reality. If you take this seriously, it'd imply that reality itself depends on who's observing what. A few months ago, David Chalmers and Kevin McQueen wrote a paper about this. For a paper by two philosophers, it isn't bad. My major misgiving about their consciousness-induced collapse model is that it's unnecessarily complicated.
Okay, so I'll return to that talk. Her actual talk is well over an hour, so I'm just showing small clips here. So she mentioned this paper on consciousness and the collapse of the wave function by Chalmers, who's a well-known philosopher, and Kelvin McQueen as well. And what they conclude at the end of that paper is not that consciousness collapse interpretations are clearly correct, but that there was a research program here worth exploring. This is new. There's a significant change that has happened in the academic world, especially among philosophers, but increasingly among neuroscientists and physicists as well, on whether or not even the dialogue about this question is legitimate. Well, yes, it is now a legitimate question, and there is a research program here worth exploring. So let's return to Sabine.
Okay, so here we have people thinking that it's somehow the amount of consciousness in a system that induces collapse, which is kind of weird already. But there are also people who think that deliberately focused attention actually influences how a system collapses. This idea was also brought up by Wigner, though I think it wasn't his intention. In 1967, Wigner published a very influential essay titled Remarks on the Mind-Body Problem, in which he wrote, "We do not know of any phenomenon in which one subject is influenced by another without exerting an influence thereupon. It's not a big step from there to conclude that if conscious knowledge can be influenced by the result of a quantum experiment, then your conscious knowledge can also influence the result of a quantum experiment." Now, add to this that back then, scientists were still experimenting with telepathy. Some of them were also studying if concentrating on the outcome of a random number generator would change the outcome. It was just a small step from there to the idea that if you focus your attention on photons going through a double slit, that affects the pattern on the screen. I'm not making this up. This is literally how those experiments work. There have been a few of them since the 1990s. The most recent one was published in 2020. The idea is that when a conscious being concentrates on the light passing through a double slit, then that has a similar effect as if you had measured which slit the light went through, so the interference pattern should change. The authors describe the experiment as follows. It was explained to the participants that they could try to mentally see or image which of the two slits the photons were passing through, to become one with the optical system in a contemplative way, to mentally block one of the two slits, or to mentally bend the laser beam so as to cause it to pass through one slit rather than both. They then statistically analyzed the difference in the interference pattern between the cases where the participants were told to concentrate on the double slit and not. The authors claimed to see a statistically significant difference. Their analysis method was later criticized by another group, which argued that the method of analysis is unreliable and the results can't be trusted. Similar criticisms have been raised about earlier experiments. How difficult can it be, you may ask, to figure out whether the pattern of a double slit changed? Well, the issue is that the common illustration with multiple stripes for the unobserved double slit and two thick bands for the observed one is so misleading I can only call it wrong. It's because a single slit also makes an interference pattern. It just looks slightly different from that of a double slit. So if you don't expect your conscious observations to affect really each photon, it can actually be difficult to tell the difference. There'd be easier examples to look at, but maybe they didn't want that. In any case, the brief summary is that the results of experiments that claim to find an influence of conscious thought on the outcome of quantum experiments have remained highly controversial and have not been reproduced. In addition, the idea that your conscious attention somehow influences what the wave function collapses into doesn't make sense. Wigner was right in saying that in physics, if one thing can affect another, then that influence can go both ways. But that doesn't mean that the influence is equally relevant in both directions. If it rains, you'll get wet. If you swear at the sky in response, then the pressure waves coming out of your mouth move some air molecules, so they indeed influence the rain. But for practical purposes, it doesn't make any difference. And your brain indeed has a physical influence on its environment. That's because thinking generates electric and magnetic fields, but they're too weak to collapse the light going through a double slit. I believe.
Okay, so with all due respect to Dr. Assenfelder and also to other physicists who would say similar things, I think there's a bit of a problem here in terms of what is being presented. And the reason why I chose Sabine in particular is because almost 600,000 people have seen that. And if they don't know that there's actually an alternative explanation as to what's going on here, they will be influenced to believe that she's probably telling you what's correct, but it actually isn't. So let's look at some reasons why. So first of all, she said that Wigner's article was published in 1967. It really was 1961. That's just a trivial problem. But what Wigner also said in that article, which is quite good, you can find it on the web. He said, one may well wonder how materialism, the doctrine that life could be explained by sophisticated combinations of physical and chemical laws, could so long be accepted by the majority of scientists. To which he responded to himself, the reason is probably that it is an emotional necessity to extol the problem to which one wants to devote a lifetime. He goes on to say that under the usual conditions of experimental physics or biology, the influence of consciousness is certainly very small. We do not need the assumption that there is such an effect. But the same may be said of the relation of light to mechanical objects, in other words, light pressure. Experiments that demonstrate the effect of light on the motion of mechanical bodies are difficult. But it is unlikely that the effect would have been detected at all had theoretical considerations not suggested its existence and its manifestation in the phenomenon of light pressure. So how would you detect a mind-matter effect? By discovering phenomena in which consciousness modifies the usual laws of physics, so says Wigner. Only very crude observations of this type have been undertaken in the past. This would be pre-1962. And all these antedate modern experimental methods. So far as it is known, all of them have been unsuccessful. That's not true, as we'll see. However, he goes on, every phenomenon is unexpected and most likely until it has been discovered, and some of them remain unreasonable for a long time after they have been discovered. So that's part of what Wigner says in this very interesting article. So then Sabine goes on to say, well, if you swear at the sky, the pressure waves do indeed influence the rain, but for practical purposes, it doesn't make any difference. To which my response is, science seeks knowledge about the natural world. It is not about practical applications or practical purposes. Sometimes it could take very long periods of time, decades, sometimes centuries, for scientific knowledge to become practical. So I don't know what she's talking about here. One would think that a physicist is not concerned about practical purposes when you're on the leading edge of what is known. Then she says, I'm not kidding. Back then, some scientists were still studying telepathy, and if concentrating on the outcome of a random number generator would change the outcome. So this is using ridicule to dismiss an entire body of data. And so I'm going to be harsh with her here because two can play the ridicule game. So I'm going to play this clip.
What you just said is one of the most insanely idiotic things I have ever heard. At no point in your rambling, incoherent response were you even close to anything that could be considered a rational thought. Everyone in this room is now dumber for having listened to it. I award you no points, and may God have mercy on your soul.
This clip is one of the more famous movie insults. It comes from the movie Billy Madison in 1995. So first of all, we know that interaction-free experiments show that knowledge alone can collapse the wave function. So it does raise the question, as Wigner and many others had said, well, can one gain knowledge via ESP? does consciousness play a role in the physical world? Well, so you can go look in the mainstream. This article was published in 2018 in American Psychologist, so it was before Sabine gave her talk, so there's no excuse for not finding it. And you look at the experimental evidence for parapsychological or psychic phenomena, ESP, you find there's an enormous amount of evidence. This article here was looking at 10 different meta-analyses of different classes of studies that have been done over the past 100 years or so. And it's been looked at a huge number of times. This is an impact factor made by a company called Altmetric, which tracks millions of published articles in the peer-reviewed literature. So top 5% of all research outputs, 99% compared to outputs of the same age, and 99% high attention score, also compared to articles of the same age. So people are paying attention to this, apparently not Sabine. So the bottom line for this article was the evidence is comparable to that for established phenomena in psychology and other disciplines. We're talking here about psychic phenomena. And likewise, in 2016, the president of the American Statistical Association also said this, that the scientific data in support of precognition and possibly other related phenomena are quite strong statistically and would be widely accepted if they pertain to something more mundane. You can find even more recent effects. The articles, these came out, I think, this year, looking at what's called an umbrella review, looking at many different meta-analyses, in this case for anomalous cognition, which is the polite academic way of talking about psychic phenomena. So they looked at over 80 years of investigation, 11 meta-analyses, and the evidence clearly shows that anomalous cognition seems possible. And that's said in a way to make it academically acceptable. It's actually not that it seems possible, but the effects are actually very, very strong because of so much data that's been collected. Likewise, this just came out in the Journal of Scientific Exploration, a review and meta-analysis of remote viewing data. And one of the ways that they talk about it, there's lots of different statistical methods, but they used a Bayesian approach. And a Bayesian approach is the Bayes factor is 530,000 to 1, means the odds against chance that the effect is in support of the hypothesis of remote viewing is real, 530,000 to 1, more or less. And a Bayes factor greater than 100 to 1 is considered decisive evidence. So we have here 530,000 rather than 100. So you would think this is way beyond decisive evidence that remote viewing is a real thing. Likewise, anomalous perception in a Ganzfeld condition. This is primarily looking at telepathy tests. And again, in this case, the Bayes factor is 1,909, which is not quite as good as remote viewing, but still, if decisive evidence is 100 to 1, and here we're talking about something 20 times more than that, it's pretty good. So the overall picture emerging from this particular meta-analysis is that there is sufficient evidence to claim that it is possible to observe non-conventional anomalous perception in a Ganzfeld environment. Again, said in academic terms to make it nice and clean, but they're talking about telepathy. As far as influencing random number generators, the Pear Lab at Princeton University did this for almost 30 years. There's their random number generator based on a quantum indeterminate randomness. And what they found was that over many, many people and many, many trials, if you ask them for a random number generator to produce more 1 bits than 0 bits, that cumulatively over a long period of time, that is what you get. And if you ask them to produce more zeros and ones, that's what you get. If you ask them to not do anything, it meanders around a baseline of 0 or a chance. So when I was at Princeton, my colleague Roger Nelson and I did a meta-analysis of all of the random generator experiments that were done at the time. Over 800 were found in the literature, and we found unequivocal positive results in experimental conditions and chance results in control conditions. There have been several other meta-analyses done since then, and with some controversy, of course, because of the nature of what we're proposing here. But nevertheless, all of them have found various ways of looking at the data and suggesting that there are positive results. Somehow focusing your attention at what should be a random event is no longer random. And then you can look back now at an interesting historical thing. This is 1965 in the journal Science, which is one of the top 2 rated science journals in the world. This article, Extrasensory Electroencephalographic Induction Between Identical Twins. So that was published, supported by the NIH grant in 65. In 74, we have another major article in Nature. In 76, a major article in Proceedings of the IEEE, which in the engineering world is the top journal. And then in 82, yet another article in the Proceedings of the IEEE. And so this is pretty much among Science and Nature and Proceedings of the IEEE, which are the top tier journals. You don't generally find these kinds of studies anymore in these journals. And you figure, well, what happened to them? Well, for many years, my colleagues and I were wondering, well, how come this showed up in Science? Because it actually wasn't such a great experiment. As one of the criticisms at the time by parapsychologists was that if that study was submitted to a parapsychology journal, it would not have been accepted. So what was going on? So why did it get accepted? Well, we finally discovered why. A couple of months ago, I get an email from somebody in another country saying, do you ever know what happened to this study? Did they ever do any follow-up? And because this person found something called this, coincidence of EEG alpha patterns in humans by the same 2 authors, which as far as I know, our colleagues never knew anything about this. And not only that, it was published, it was a contract by the Office of Naval Research. So if you go back and you start looking for this NIH grant, you can't find it, which suggests that maybe the NIH administered the money, but the money was probably coming from somewhere else, like the Office of Naval Research. This study by the same authors was a follow-up to the original study and was much more successful than the original study, and it was never published. The only way I was able to find this was go to a government website that publishes military reports. And I asked them, do you have something of this title by these people? And they spent a while and said, yeah, we have it, but no one's ever requested it before. So we can scan it for you if you want. So it goes through the whole Freedom of Information Act, and they scan it. And a couple of months later, I get it back and I look at it. And sure enough, they did do the experiment. It did replicate right around the same time that the US government created the Stargate program, which was classified. So my guess is that there's long been interest in many governments around the world about psychic phenomena, especially for the use of it in intelligence purposes. And so bits of money here and there were given by places like the Office of Naval Research, and getting back data from people, which was quite interesting. So this ultimately was interesting enough to people in Congress, and then was given to different agencies to create the Stargate program, which was a 20-year program using psychic phenomena for espionage. So I think one of the reasons why these mainstream papers began to disappear is because somebody was telling the editors or something. I really don't know, but it kind of suggests that there was a suppression of it's okay if those crazy parapsychologists talk about this, but we shouldn't make this look mainstream, because it reduces the value of having a program, a black program, that is actually using this stuff. In other words, if you have a secret weapon, you don't want to let your adversaries know that you have it. So let's make all that psychic stuff go away. All right, we'll return back to Sabine. Sabine mentions one of the articles that I published. This one involved 6 different experiments, and which is true. It provides statistical evidence in favor of the consciousness collapse interpretation. And then she brought up this response to it, and she said, well, but it's unreliable. That's my response to that question, because it's much more complicated than that. But she basically uses this as a way of dismissing, well, that this stuff, nobody knows if it's real or not. And in particular, she says the experiments have not been reproduced. Well, that is an important criterion in science. If you cannot reproduce an experiment, then the jury is out. You don't know whether it's real or not. Oops, that is wrong too. As of November of 22, when the video came out, there have been 5 laboratories that reported the same kind of experiment. My lab is just one of them. In addition, earlier this year, there was an independent review published that had a positive conclusion after reviewing all of these studies. In other words, if you look at all of the published studies, your conclusion, and I didn't know these authors, I didn't even know that they were doing such a review, but it got published in a journal, and they said, yeah. And then she ends this clip with thinking generates electromagnetic fields, but they're too weak to do anything, to which that is my response. Because if we go back and look at the origins of quantum mechanics, especially Max Planck, who was the one who came up with the idea of a quanta, regarded consciousness as fundamental. He was a philosophical idealist, as were almost all of the founders of quantum mechanics, some of whom, like Jordan, actually published articles in parapsychology journals. So even contemporary physicists agree that that there's something interesting going on with consciousness. And I have a much longer talk about John Wheeler about this, and that's also a very interesting study in cognitive dissonance, let's say. So many people don't know that the quantum mechanics began essentially as kind of a mystical tradition. And so this article in the European Journal of Physics talks about a mystical hypothesis, one shaping the mind, not the brain, a role to play at the material level of reality shaped the way that physicists understood quantum mechanics, even at the level of fundamental equations. So we're all the way back to the beginning. Quantum observer effect, we already discussed. And you also heard Sabine talk about this idea of how do you break the chain? This is where von Neumann comes in. So one way to illustrate this is, how do we see a butterfly? Well, a light photon bounces off a butterfly, and this can be described in quantum mechanics either as a wave function or as a matrix of numbers. Well, what then happens? The photon that bounced off the butterfly goes into a camera, goes onto a screen. We look at the screen. Our brain is processing the information, and then something magically happens, and we see a butterfly. So if we look at this from the point of view of the mathematics, we have a photon, a description in this case as a matrix, and a camera and a display in the eye and the brain. These are all physical things. There's no consciousness in there yet. When a photon and a camera interact, we have a superposition is created. In matrix terms, you create a tensor product between the two objects, and it's simply just another more complicated wave function or matrix. And the same with display, same with the eye, same with the brain. All you're doing here is creating more and more complicated physical systems. So far, none of it is seen yet. It hasn't existed in the physical world as we experience it. So this is a sketch drawn by John Bell, who of course was the one who came up with an idea, a way of testing for entanglement. And he was the one who coined this notion of how do you break the von Neumann chain? In other words, the quantum world is described in this wavy fashion, but we live in a kind of a classical world. Where did this come from? So von Neumann suggested that measurement chain ends only when knowledge of the measurement is registered by an extra physical factor, by which he meant consciousness. And if you look in Wikipedia and you ask, what are the various interpretations of quantum mechanics? There it is. Consciousness causes collapse. And it creates a causal role for the observer. This is the only one of these interpretations that creates a causal role, even though other ones are not quite sure. There are 2 others that have an intrinsic role. So it's not the case that physics has kind of wrapped this up. There's lots of disagreement and uncertainties about what's going on here, but the important point about this is it is testable. So here was a survey sent in 2016 to over 1,000 physicists, of whom 149 responded. And they were asked, in your opinion, the observer, a bunch of questions. 22% said it plays a distinguished physical role. That's what von Neumann and all of the other physicists said. That means that roughly 1/5 of contemporary physicists think along the lines of von Neumann, and this is not crazy. This is not tinfoil hat stuff. This is actually for people who are specifically concerned with the foundations of quantum mechanics. And as I said, it's a testable idea. So you can take a double slit system, very simple, it's a laser, a neutral density filter to cut down the illumination, a double slit, and then some sort of a camera or screen that catches the result. So the first two experiments looking at this issue were published in the Journal of Scientific Exploration, 1998. So the first one was Stanley Jeffers at York University, and then Mike Ibbison at Princeton. This is their setup. It's a classic double slit setup. So the first experiment at York University did not show any interesting results. So the results would have to go outside of this 95% confidence interval to show a cumulative result. They then gave their apparatus to Princeton, which improved it somewhat. And then they did get a significant result at Princeton. And then afterwards, a secondary analysis of the York University results did show a significantly elevated variance, which you would not see in this kind of graph. And the control run showed a chance expected variance. And I'm going to return to this idea of variance. The distinction here is that this is called a mean shift analysis. If everything is always going in the same direction, then as you accumulate the result, it's going to start drifting away from chance. If you have a variance effect, you wouldn't see that. You could very well see something that's fluctuating up and down from chance, but too much. And in this case, the variance was too much for the York University results. So then we started doing a replication of the same idea. The only difference that we did from what you would do in a physics lab is use people to gain knowledge about what's going on in the double slit, similar to what Sabine had described it as. That's what we were asking people to do. So there's the double slit slide. There's this piece of metal over here, and it's inside this big thing to hold it. And then we have a line camera to look at the interference pattern. That's what the line camera sees, this alternating light and dark bands. If you draw that as a graph, as illumination graph, you can see it has this nice shape. That's what the system looked like when it was all sealed up. So this is a 1/4 inch of aluminum. Everything's painted flat black. The camera is over here. The double slit's inside there somewhere. You can make other double slit systems. This one is made completely out of commercial stuff. The other one we had fabricated. A colleague of ours actually made it. But this one's made out of parts you can just buy. It's around $10,000 worth of stuff. So there again is what the camera sees, the illumination level. And so if you take a Fourier transform of this, you end up with something with 3 peaks in this case. So this first peak is this very slow moving shape here. And we're looking at this in spectral terms. The spectrum is like a slow moving wave. Second peak is these fast moving waves. This is the interference pattern. And this third peak is a harmonic of the second peak. So the measurement that we're taking then in this experiment is to look at how this second peak changes. Because if observation is causing this shape to change, then that peak is going to go up or down. So we're looking for changes in that peak. So the experimental protocol is very simple. Compare the interference pattern according to that peak during mental observation versus no observation. Observe for around 30 seconds, rest for 30 seconds, plus a little bit of additional randomly, and repeat it. This is a differential measure looking for, does mental observation affect interference at all? So we did a bunch of pilot tests in 3 different groups of people, all people together, non-meditators and meditators. The meditators did really, really well. And in the same direction. Each experiment, even using different protocols and different groups of people, when we ran it as a control, where nobody was trying to mentally do anything, you get results according to chance. And so all pilot studies together showed, with all data, an interesting, significant effect, most of which was due to the meditators, not to the non-meditators. And again, the controls were at chance. We then were asked by one of our funders to do a formal test, 50 planned sessions with 50 people to see if we would get reduced interference. Would we see a change in the interference pattern? The answer was yes. This is a 5 sigma result. 5 sigma within physics is considered a discovery of something. So we published that in 2012. And then people started saying, well, maybe the results that you got were due to the proximity of the human body. And the reason this comes up is because interferometers are very sensitive to things like temperature changes. And in our experiment, we had people about 2 meters away, roughly 6 feet away from the interferometer. And we figured, well, maybe with effort, they were leaning towards the interferometer when they were trying to mentally project themselves into it, and then leaning away when they were in a control condition. And there would create a very small change in temperature, but maybe enough to produce this effect. So we did an online version of it. So here's the interferometer, but it's going through a server. And over 3 calendar years, we did 4,500 sessions where humans went to a web browser and mentally through the web browser were seeing the results of the experiment and tried to interact with the system. And also 7,000 sessions run by a robot as a control, a Linux system. So in the non-observing case, a person would go to a browser and just see this blue rectangle. And in the observing condition, they would get real-time feedback about how much interference there was, what the shape of that interference pattern was. So the more that it went up, it meant the more that the interference pattern was collapsing. So the goal in this was concentrate on the graph, which was then linked to what was going on inside the box, and make the graph go up. And in the not observing case, a Linux box would get exactly the same stuff. The double slit system, of course, did not know who was observing. The data was just being delivered to something. So it was either a Linux box or a human. And so the measurement in this case was a little bit different. One of the ways you can measure an interference pattern is by what's called fringe visibility. How visible is that fringe? And it's very simple. You look at the maximum and minimum, you take this proportion, and so you're looking at the difference between these 2 dots. And the prediction would be that the visibility would shrink when humans were doing this task. So it would go down. And so these black dots are when humans were doing the task, and the white squares were when the Linux box was doing it. Highly significant difference between these 2 conditions. And the other thing you could tell by this is we knew where people were from by looking at their IP address. So we're able to, first of all, say, here's chance. Chance expectation would have been 0 effect. But this is what we actually saw. And so it's a small effect, but more importantly, it was basically the same regardless of where people were. So some people were within a couple of kilometers of our laboratory, up to 18,000 kilometers away, which was from where our laboratory was, would have been South Africa. And the fact that there was no difference in the effect size tells us that the effect of consciousness, in this case, apparently, is independent of distance. Well, then somebody said, well, maybe you're just seeing some sort of statistical effect. What if you use single photons in this experiment? And so this is a single photon double slit system. With this kind of system, you shoot a single photon, it goes through a double slit, which is underneath the Buddha there. And then you have a photomultiplier tube to see how many photons do you get. So you can't get an interference pattern. All you get is a number of counts of photons. But what you can do is move the slit in front of the photomultiplier and see whether you're getting an interference pattern, which I'll talk about more in a minute. But so we used something we call the illuminated Buddha feedback. So inside the Buddha, there's a LED, and the LED would shine brighter if there were more photons that were seen by the photomultiplier. The experiment was done in complete darkness, so the only way that you could illuminate the Buddha was by being successful in this task, and people liked this. It was very motivating as an experimental form of feedback. So if you move the slit in front of the photomultiplier, in fact, you get a nice interference pattern, just as you would if you were using a camera with lots of photons. But we only can see we only looked at one particular place on this graph, which was right there. So we put the slit in front of that portion of the interference pattern, and if the interference was happening, it would cause a change in the interference such that the top would go down, but the bottom would go up. So the task in this case was for people to get more photons to show up right there, and they did significantly. So this would say that the effect was even occurring at a individual quantum event. which is what we kind of suspected, but we needed to run the experiment to find out for sure. Okay, we did, and we ended up doing something like 18 experiments using different methods. But the fourth independent replication was a physicist who had been at CERN, who decided that what we were doing was more interesting. So he spent a month with us. He went back to the laboratory at Sao Paulo, Brazil, created his own setup, and then reported, this is not yet published, but reported 6 exploratory experiments with statistically significant unidirectional differences, mean shift differences, very similar to what we had been seeing. He then did 3 formal experiments, which were not statistically significant until he looked at it to see if there were variance differences. So once again, we're seeing interesting results in variance. The 5th replication, I did not know these people. I still don't know them, although I exchanged an email with the first author. This is a combination of people from a university in Serbia and another one in Moscow who did another replication, same kind of idea. 26 people. They also were wearing EEG systems. And the results said, we confirmed that attention affects the electromagnetic wave, which is how they were imagining what was going on, causing wave function collapse in a double-slit optical system. Radin observed significant changes in the electric field ratio and the concentration versus relax condition, exactly what we observed in our study, which was nice. So these are all the published studies that we know of people that have been replicating these kinds of things. Total of 30 reported experiments, of which 14 are significant at 0.05 level two-tail. The probability of seeing 14 experiments that are significant two-tailed out of 30 is about a 6 sigma result. That's very unlikely to occur by chance. So it's not a way of doing a formal meta-analysis, but a kind of an easy way of seeing, is this the results that we're seeing chance or not chance? So far it looks like this is not a chance effect. And more importantly, it has been replicated now in 5 different laboratories. Actually 4 labs, because at York University, the way they reported it was not significant until you look at the variance, in which case everyone that has done this experiment is seeing a significant result. So this is the result I mentioned in Progress in Brain Research, which reviewed these studies. There's the abstract, and their conclusion is this. These studies suggest that mental activities are capable of influencing physical systems. So again, this is from University in Ireland. I did not know these people beforehand, just sort of accidentally found this article, and they agreed that something interesting is going on. Now, within parapsychology, people have been discussing these kinds of ideas, the relationship between quantum physics and parapsychology, since the 1950s. So this was a Journal of Parapsychology issue that reported on a conference about this topic. And it included Gerald Feinberg, who was a Nobel laureate, also very well-known physicist, Olivia Costa de Beauregard, and many others who are talking about the quantum perspective of these kinds of effects and the relationship to parapsychology, because there is one. The Pear Lab in Princeton, of course, did these experiments as well. And I've already gone through this, so I'm going to just jump right through all that. What's less well known is that Jaap Houtkooper did his doctoral dissertation and published a summary of it in the Journal of Scientific Exploration, in which he talks about what was developing within parapsychology called the observational theory. And he defined it as the act of observation by a motivated observer of an event with a quantum mechanically uncertain outcome influences that outcome. That's the theory. These influences would not be constrained by ordinary space or time because it's a quantum event, and it predicts a retro psychokinetic effect. The way it would work is you record unobserved random data coming from a random generator. You record that now, and then tomorrow or sometime in the future, you will be asked to mentally influence the pre-recorded bits. This is why it's called a retro psychokinetic effect. Interestingly, this came out just a couple of days ago about backwards time effects from the Department of Physics at Cavendish Lab, University of Cambridge. We're not proposing a time travel machine. but rather a deep dive into the fundamentals of quantum mechanics. These simulations do not allow you to go back and alter your past, but they do allow you to create a better tomorrow by fixing yesterday's problems today. That is more or less how these experiments worked. So if you look at a meta-analysis of this, the first in 1975, the last known is 1993, overall a 5 sigma effect, which again, in a physics perspective, this would be considered a discovery. This is a retroactive PK project. This was the first parapsychological theory leading to a prediction and a subsequent confirmation of a new effect that was not previously observed or even imagined to exist. So today within quantum mechanics, we have results like the delayed choice experiment, which again is showing there's some strange temporal effect going on here. But these were done well before the delayed choice effect was being studied in a parapsychological context, and it works just as well as it does in the delayed choice experiment. So the summary so far is this: 90 years of experimental evidence for the reality of mind-matter interaction, and it provides growing support for the consciousness collapse hypothesis. And this has even been talked about in Nature. So in July 2015, the author was writing about the mental universe. The only reality is mind and observations. But observations are not of things. To see the universe as it really is, we must abandon our tendency to conceptualize observations as things. So, implications. First of all, the implication is that consciousness plays a fundamental role in the physical world. That doesn't mean that it's primary over the physical world yet, but it plays a role, a direct role in the way that the physical world unfolds. Maybe it is fundamental. We don't know that for sure yet. The scientific evidence supporting this idea is continually improving in credibility and impact. Scientific interest is rapidly expanding. There's new academic openness to esoteric and indigenous beliefs about mind and matter. For example, the University of South Carolina and Exeter University in the UK both have created graduate level degree programs in magic. So I'm not sure whether they use that term. They might calling it something like esoteric practices, but you can now get a master's degree in what amounts to magic. In the academic world, it's still not acceptable to say that things like magic are real. You can talk about what people believe that might be real, but nevertheless, I think that's going to change because, as I said, the evidence that mind and matter really do interact and are very closely related to these beliefs is beginning to penetrate into the academic world. There's still a lot of skepticism about the reality of consciousness playing a role in the physical world, and I would say it's primarily due to hubris and to stigma. This is why when a mainstream person is talking about this stuff, they will wear a tinfoil hat, or they'll point to a tinfoil hat. That's creating stigma. But it also is due to a lack of appreciation about the history, the sociology, and the philosophy of science. Like if there's anything that we know that we don't really know what's going on, even in physics at a fundamental level. But nevertheless, that for a science spokesperson who has a big audience to not talk in terms as though they really don't quite understand what's going on, that wouldn't go over very well. People want to have explanations for things. But the reality is we need to be extremely humble about what we think we know because we don't actually know that much yet. Science is new. Implication 2, today's quantum mechanics, what we can think of as the orthodox mathematics of quantum mechanics, is a linear theory applied to systems that are in equilibrium. The real world is nonlinear and far from equilibrium. So quantum mechanics 2.0 will probably be much stranger than quantum mechanics 1.0. If we're at 1.0 today, the next version of what's going on here, when we start using nonlinear quantum mechanics that are far from equilibrium, will be much, much stranger. It may allow, for example, for entangled information transfer. So quantum mechanics 1.0 does not allow for information transfer. I think 2.0, there are models out there suggesting that, yeah, you could do information transfer, in which case telepathy immediately will become recognized as a thing that can happen. Quantum mechanics 2.0 may also reveal new insights about the observer effect and, more importantly, the importance of the observer effect. we're still at the very earliest stages of understanding both mind and matter. So any statement offered today about what's impossible or supposedly impossible because of it might violate physical laws is somewhere between certainly wrong and simply a lack of imagination. Because, as I said, we're at the earliest stages of understanding what's going on here. So where do advances come from? They'll come from new ways of observing what's going on. That means new instrumentation, new hypotheses, which will force new theoretical developments, which will in turn predict new ways of observing, and the cycle will go around and around. So in general, what I usually try to remind people is that don't look at my hand, don't look at quantum mechanics today as a way of saying that we understand everything, because we don't. Instead, I'm saying, look at where I'm pointing. I'm pointing at a trend in physics and in other disciplines as well, in neuroscience and in philosophy, that are pointing towards some point in the future, I think, which will converge with what we experience as psychic effects and what is said in the esoteric literature and is understood within spiritual experiences. They're on a collision course. When that occurs, it's very difficult to say. I think we're somewhere between decades, maybe centuries away from actually being able to combine all of these different ideas into something where we have really good explanations for it from a scientific perspective. We're not there yet, but that's where we're going, I think. So I asked this AI program to give me a picture of someone walking down a hall of mirrors. That's what it came up with. It's not too bad. And so I need to acknowledge here all of the different foundations and individuals and also the donors and members of the Institute where I work, because that's how this research gets done. We don't get government funding. We don't get any other funding than foundations and individuals who are interested in this kind of work.